Hey, it's Mr. Russell, and we're here to balance redox reactions by the tie method. And you're probably thinking, is he going to wear this tie the whole video? Yeah, I am. This is the ugliest tie I own. Um, when we look at these redox reactions, we're looking at the charges, okay? You guys can see that these masses do balance out. If I have one copper here and one copper here, so that balances, and then one silver here and one silver here, that balances according to the mass. But now take a look at the charges. So let's assign some oxidation states first. Copper is going to be 0, and then silver is going to be positive 1, and then this silver is going to be 0, and this copper is going to be a positive 2. So this whole net charge here is going to be a positive 1. And this whole net charge is going to be a positive 2. So where did that charge go? That's not right. We have to have the same charges on the left as we do on the right. So, or else the whole universe would collapse. Mass hysteria, dogs living with cats. I mean, it's just crazy. So, let's go over the rules for it. Here are the rules for balancing. We want to write the unbalanced equation first. Then we're going to determine the oxidation states. I want to show the electrons gained and lost by using the ties. I'll show an example and we'll use coefficients to equalize the electrons. So this is called the factor. I call it the factor step. Then we're going to balance the rest of the equation if we have to, and then add all the appropriate states. So you'll need to remember that metals with an oxidation state of 0 are solid. Actually, except for mercury. Mercury is the only one that likes to be a liquid at room temperature, but everything else is going to be a solid at oxidation state of 0. So here's the example from the beginning. I've already written the oxidation states in there, so that takes care of the first two steps. So the next step is for me to go ahead and draw the ties. So that means I'm going to draw in a red tie here for copper, and I'm going to draw in a blue tie here for silver. And just because I'm on the blue pen already, I'll go ahead and do this one. So I go from a +1 charge to a 0. So think, is it gaining or losing electrons? So it went from a +1, so it gained, and to a 0, so it gained a negative charge, so it gained 1 electron. So I'm going to write 1 electron gained. Okay, and then I'm going to go to the red pen, and it goes from a 0 to a positive 2. So that means that there are 2 electrons lost. Anytime you gain electrons somewhere, you're going to lose them somewhere else. So you'll always have an oxidation and a reduction at the same time. You never have just one. They always exist at the same time. Now I could apply my oil rig mnemonic where oxidation is loss. So now that I know that copper is oxidized and then silver is reduced. So now to balance it, I need to make these two numbers the same. So I need to make, so what I'm going to do is I'm going to multiply this one by 2. And so when I do that, I'm going to take this 2 and I'm going to put a 2 in front of the silver. So that it will now multiply by the charge. The coefficient will multiply by the charge, and now it is balanced. Now I will have to, I'm actually going to go back to the previous slide where it says that I need to balance the mass of the equation. So what that means is whenever I put that 2 in front of this silver here, I just now unbalance the mass. So I'm going to have to put a 2 on this side so that my masses are balanced. And now 2 times a 0 is still going to be oxidation state of 0. So that's going to work out. The state symbol is already there, so we're done. We'll do another example out of the textbook that's on page 177. This is a redox reaction, and we're going to have to balance the mass and the charge. So notice that the masses aren't balanced yet because I've got one nitrogen here and two nitrogens here, and then the hydrogens aren't balanced either. So let's balance the charge first, and then we'll balance the mass. So what I'll first do is I'm just going to drop these state symbols because they get cumbersome. I can drop them now and then put them back in later. Okay, now I'm going to put the oxidation states on all of these, and I'm going to go all over the place. But this one's easy. This one's a 0. Oxygen's a -2, and then hydrogen is going to be a +1 because 2 times +1 is +2. It cancels out. This is going to be a 0. Hydrogen is a +2. That makes nitrogen -3. -2, and then this makes this a +2. Now that I've done that, I can just try to see which ones are actually changing. So I'll look at lead first. So lead is going to go from a +2 to a 0. So that's changing. So I'll just put a check mark. And then oxygen is going to go from -2 to a -2. So that's good. Nitrogen is going from -3 to 0. So that changes. Hydrogen goes from +1 to +1, so it doesn't change. So the ones that do change, I'm going to leave the green numbers in, but the ones that don't change, I'm just going to take them out. Okay, now I can do the tie-in method, and I'm going to tie in the lead together in blue. And I'm going to tie in the nitrogen in red. Okay, no difference. I just drew them in different colors. Red doesn't mean anything, or blue doesn't mean anything. So and so my lead is going from +2 to 0. So that means that it gained 2 negative charges, right? So it gained 2 electrons. So 2 electrons gained. And then this one has 3 electrons lost because it lost 3 negative charges. Okay, so now my next objective is to try to find my factor. My factor is going to be I need to make these 2 numbers equal each other. So the easiest thing to do is multiply them by themselves. See what I did there? So now my 6 electrons is total. So when I multiply them, I need to put a coefficient in front. So I take this 2 and put it to the 2 in front that I had here. And now the charge balances. And then I take this 3 and put it in front here. And now we're good to go. So now I'll rewrite it with these 2 numbers in here. And now I will balance my masses, the things that I needed to change. So I got 3 leads here, so let's just change this to a 3. And then I got 3 oxygens, so let's change this to a 3. And then I got 2 nitrogens, that works, and then 6 hydrogens, 6, hey, that works. Okay, so that's a balanced equation by charge and by mass. Very, very nice. So now I will have to, oh yeah, put my state symbols back in. That's right. So I'll just have to copy and paste all the ones that I had before. Since it gave it to me at the beginning, I don't really have to think too hard. Just recopy. And that is it. That's going to be my answer. Thanks for watching, guys. Takes a lot of practice, but it's actually a lot of fun.